The story of the cosmos begins with fire, a singular moment when all of space, all of time, and all of energy erupted into existence. The Big Bang, the beginning not just of stars and galaxies, but of the very fabric that carries them. To speak of the universe is to speak of 13.8 billion years of unfolding, a history measured in light, and yet hidden in its glow. There are whispers of something older, a relic that should not be, an object, a signal, a fragment of matter or pattern of radiation that seems to carry memory from before the beginning itself. It is as though among the ruins of time, archaeologists unearthed a stone carved before the earth existed. But here, the relic is stranger, a star that seems older than the cosmos it inhabits, a signal in the background radiation that does not belong, particles that refuse to decay, as though they were born in a universe prior to ours. Science has built its greatest monuments on the belief that the Big Bang was the first page of the cosmic story. But what if it was not the beginning? What if it was only a chapter, following a history erased, yet not entirely lost? The relic older than the universe is not fantasy. It is a paradox suggested by data, by equations, by the faintest imprints in light and matter. If it exists, it changes everything: the origin of time, the permanence of laws, the definition of reality itself, a fossil from before creation, a memory older than the cosmos. The question it raises is simple, yet terrifying. How can something outlast the universe? And what does it reveal about the truth of time? The mystery of the relic begins not with paradox, but with triumph. In the early decades of the 20th century, science uncovered the first great evidence that the universe itself was not eternal and unchanging, but dynamic, alive, and evolving. The rise of the Big Bang. The story begins with Edwin Hubble standing at the eyepiece of the 100-inch Hooker telescope atop Mount Wilson in California. Through its glass, faint smudges of light resolved into galaxies, island universes, vast seas of stars drifting far beyond the Milky Way. By measuring the light of these galaxies, Hubble discovered something astonishing. The farther away they were, the faster they receded. Space itself was stretching, carrying galaxies apart. The implication was unavoidable. If the cosmos is expanding today, then long ago it must have been smaller, denser, hotter. Projected backward, all galaxies converge into a single primordial moment, the birth of time itself. In the decades that followed, this idea grew into the Big Bang theory, a model of cosmic origins that transformed science. Then, in 1965, came the accidental confirmation. Two young radio astronomers, Arno Penzias and Robert Wilson, working at Bell Labs, encountered a faint hiss of microwave static that would not go away. They pointed their antenna across the sky, cleaned it of nesting pigeons, and still the signal remained. It was everywhere, uniform and ancient. They had stumbled upon the cosmic microwave background, the afterglow of the Big Bang itself. With this discovery, the Big Bang ceased to be speculation. It became the central framework of cosmology. The universe was not eternal. It had an age, about 13.8 billion years, measuring the age of creation. The age of the universe was pinned down through multiple methods. Astronomers studied the rate of cosmic expansion, the glow of the microwave background, and the life cycles of stars in ancient clusters. Each path pointed toward the same answer: a finite beginning, a cosmos just under 14 billion years old. For a time, the picture seemed complete. Humanity had traced the origin of all things to a moment of fire and light, and the relics of that birth were written across the sky. But then came the anomalies, the puzzle of ancient stars in the 1990s. Astronomers studying globular clusters, dense, spherical gatherings of stars orbiting galaxies, ran into a problem. These clusters contained some of the oldest stars in existence, low in heavy elements, forged in the earliest epochs of cosmic history. Yet when their ages were calculated, the numbers did not fit. Some appeared to be 15 or even 16 billion years. Old, older than the universe itself. Refinements in measurement reduced the gap, but the tension remained. One star in particular became famous HD 140,283, known as the Methuselah star. Its light suggested an age of 14.5 billion years, with margins of uncertainty that still brushed against paradox. If true, it would mean this single star carried memory. Older than the cosmos, the murmur of ancient signal stars were not the only anomaly. Strange signals appeared in the data bursts of radio waves with no clear origin, alignments in the cosmic microwave background that seemed too orderly, cold, spots in the sky that resisted explanation. Some scientists speculated that these features were imprints from before the Big Bang, scars left by collisions with other universes or by cycles of creation and destruction. If so, then the Big Bang was not the absolute beginning, but merely the beginning of our observable cosmos. The relics older than the universe would be its fossils, surviving transitions of unimaginable violence, the role of particles even in the realm of particle physics. Whispers of paradox began to emerge. Certain theoretical particles, sterile neutrinos, or even primordial black holes, could have formed in epochs preceding the Big Bang, if such epochs existed. If discovered, they would be relics, not of our cosmos, but of whatever came before it. Physicists began to speculate about pre-Big Bang relics, particles that had survived transitions of cosmic cycles, carrying memory of conditions older than the universe itself. The first flag-bearers of the paradox, not all scientists welcomed these ideas. Cosmology was built upon the certainty of a beginning, a clock that started 13.8 billion years ago. 2. Suggest objects or signals older than that clock was to challenge the foundation of the field. Yet a small cadre of astronomers and cosmologists began to flag the paradox. They were careful, cautious, but insistent. The data did not always align. Whether in the ages of stars, the tensions in cosmic expansion, or the anomalies in background radiation, something pointed toward a deeper story, a whisper of prehistory. Discovery phase of this mystery is not defined by proof, but by tension. The tension between theory and observation, between certainty and anomaly, between the universe as we model it and the universe as it reveals itself. It is here, in this space of contradiction, that the idea of a relic older than the universe first emerges, a star that should not exist, a signal that should not be, a particle that defies the clock of time. Each is a whisper of prehistory, of something that survived the birth of our universe, a memory not erased by fire and expansion, but carried forward, hidden in light and matter. And if these whispers are true, then the Big Bang was not the beginning, but only a threshold. Beyond it lies something stranger, a cosmos with a history older than creation itself. The idea that something could be older than the universe itself strikes at the heart of modern science. For more than a century, cosmology has been built upon a foundation as solid as stone, that the Big Bang marked the beginning of time, To question this is not to refine a theory, it is to unsettle the bedrock of all physics. The universe has an age. The Big Bang model is not merely one theory among many. It is the cornerstone of cosmology, supported by a triad of evidence: the expansion of galaxies, the cosmic microwave background, and the abundance of light elements forged in the first minutes of existence. Together, these lines of evidence form a picture both elegant and inevitable. From these measures, the universe has an age, 13.8 billion years, not infinite, not eternal, but finite, a number carved from the sky by data. Everything within the cosmos, stars, galaxies, planets, life must fit inside that number. And yet, anomalies persist. Stars like Methuselah, with ages brushing against or even surpassing 14 billion years. Globular clusters that appear older than their host universe. Structures, galaxies, quasars, clusters, forming earlier than expected, as if the cosmic clock ran faster in its youth, and signals in the background radiation that do not fit the script of a smooth, singular beginning. These are not small cracks. They are fractures that raise a terrifying possibility that either our instruments deceive us, or the universe is older, deeper, stranger than the Big Bang implies. The clash with physics. Why is this possibility so shocking? Because if something is older than the universe, then the universe is not the beginning. The Big Bang is more than a moment of fire. It is the point at which space and time themselves were born. Before it, there was no before. To say something predates it is to suggest that time stretches further back than its supposed origin, that the Big Bang was not creation, but transition. For physics, this is heresy. Einstein's relativity rests upon spacetime as a continuous fabric, with the Big Bang as its earliest definable moment. To speak of time before time is to question relativity itself. For quantum mechanics, the paradox deepens. The laws of particles and fields are written in the language of probabilities, of fluctuations in a vacuum that emerges from the Big Bang's fire. But if relics exist from before that moment, then the vacuum itself is not primordial, it is secondary. The stage on which quantum physics is played may not be the first stage after all. The age paradox. At the center of this shock lies the age paradox. Take HD 140,283, the Methuselah star. By analyzing its light, astronomers estimate its age at 14.5 billion years, give or take 800 million. That upper margin places it securely before the Big Bang. Critics argue that uncertainties in stellar models could close the gap, errors in opacity, in nuclear reaction rates, in the mixing of elements. And indeed, refinements have reduced the discrepancy. But the tension remains. A star that appears almost as old or older than the universe it inhabits. Similar tensions arise in globular clusters, whose ancient populations often strain against the cosmic clock. Again, models of stellar evolution can reduce but not always erase the problem. Each measurement is a reminder that the universe's age is not a simple certainty, but a number pressed between competing forces of observation and theory. The unsettling signals beyond stars lie signals even stranger. The cosmic microwave background, the afterglow of the Big Bang, is almost perfectly uniform. Yet within it are anomalies, alignments of temperature fluctuations across vast scales, cold spots that resist explanation, patterns that some claim may be imprints of collisions with other universes or relics of a pre-Big Bang epoch. Most physicists caution restraint. The anomalies may be statistical flukes or products of foreground interference, but the mere possibility that they are real unsettles the field. For if true, then the microwave background, the very fingerprint of the Big Bang, carries scars from something older. Resistance and reluctance. The scientific community has not rushed to embrace these anomalies. To suggest relics older than the universe is to question the most successful theory in cosmology. The Big Bang is tested, trusted, embedded in textbooks, celebrated as a triumph. To admit evidence against it is to admit uncertainty where certainty once reigned. Thus, many scientists frame the anomalies not as contradictions, but as opportunities to refine measurements. Perhaps stellar ages are miscalculated. Perhaps background signals are artifacts. Perhaps the Hubble constant is misunderstood. These are safer answers, answers that preserve the Big Bang as absolute. Yet beneath the surface, unease lingers. The anomalies are persistent, appearing in different forms, across different datasets, through independent methods. Each one alone may be explainable. Together, they form a chorus of doubt. The shattering thought what makes this so paradigm-breaking is not simply the data, it is the thought it implies. If something is older than the universe, then the universe is not all there is. There is a prehistory, a time before time, a hidden era whose relics survive the fire of creation and drift into our cosmos. Like fossils from a forgotten world, to confront this is to confront the possibility that the Big Bang is not the beginning, but a veil. That behind the veil lies another cosmos, another order, another reality. The shock is not merely scientific, it is existential. For if time itself stretches beyond the Big Bang, then the story of existence is longer, stranger, and far more mysterious than humanity ever imagined. The first shock left cosmology unsettled, but science does not retreat from unease. It leans closer, sharpens its instruments, and demands that anomalies either dissolve or deepen. And so began the deeper investigation, an era where telescopes, satellites, and laboratories probed the paradox of relics that seemed older than the universe itself. The Hubble tension at the center of this deeper search lies the conflict known as the Hubble tension. The age of the universe is not measured directly. It is inferred from its expansion rate, the steady stretching of space itself. That rate, known as the Hubble constant, can be measured in two ways. One method looks far into the past, using the cosmic microwave background. Satellites like Planck measure the ancient light left over from the Big Bang, fit it into cosmological models, and calculate the expansion rate implied by its delicate ripples. The other method looks at the near universe, measuring the brightness of Clifford variable stars and type Ia, supernova to track how galaxies recede today, but the two answers do not agree. The cosmic microwave background suggests one value, pointing toward an older universe. Local measurements suggest a faster expansion, and thus a younger universe. The gap is not small. It is large enough that both cannot be correct. This conflict casts a shadow over cosmology. If the expansion rate is miscalculated, then the age of the universe itself may be wrong. Could it be younger than 13.8 billion years, tightening the paradox of ancient stars? Or older, allowing relics to fit inside its span? The Hubble tension remains unresolved, a rift in the fabric of cosmology that refuses to close. The Methuselah star and its Kinno anomaly has become more famous than HD 140,283, the Methuselah star. Its light, stripped of metals, reveals it to be among the oldest stars ever known. Its calculated age of 14.5 billion years, with uncertainties brushing against 13.8, makes it an icon of the paradox. Refinements in stellar physics narrow the error margins, yet the star remains a whisper of unease. If the models of stellar fusion, opacity, and nuclear reaction rates are even slightly wrong, then the star may fit comfortably within the universe's age. But if the models are correct, then this single star is older than the cosmos itself, and the Methuselah star is not alone. Globular clusters, dense spheres of ancient stars orbiting galaxies, are filled with stellar populations, whose ages press against the cosmic limit. In their crowded brilliance lies the possibility that some began shining before the universe they inhabit. Signals in the background, beyond stars, the universe speaks in light. The cosmic microwave background, mapped with exquisite detail by WMAP and Planck, is nearly uniform. Yet within it lie anomalies. A vast cold spot, larger than expected. Alignments of temperature fluctuations across billions of light years, as though the universe carries a subtle imprint of something older, something beyond. Some physicists suggest these may be relics of a pre-Big Bang cosmos, perhaps the scars of collisions with other universes, or the fingerprints of cycles stretching back before time began. Roger Penrose has argued that circular imprints in the microwave background may be evidence of black holes evaporating in a prior universe. Their memory carried across a boundary of creation. Most cosmologists remain cautious. Anomalies may be artifacts of noise, foreground contamination, or statistical chance, but the possibility remains. The oldest light we can see may not only reveal the beginning, but hint at what came before. The particle relics their investigation reaches deeper, still into the invisible world of particles. Theoretical physics predicts that certain relics could survive from before the Big Bang, if such an epoch existed. Ixion's hypothetical particles, proposed to solve the strong CP problem, could drift through the cosmos, forming a hidden sea of ancient matter, sterile neutrinos, even more elusive cousins of known neutrinos, might carry imprints from a prehistory. And there are the primordial black holes, objects so small they could have formed in the earliest instance of existence, or even before. If detected, they would be relics older than the universe. Fossils of conditions erased from all other records. The weight of gravitational waves. New instruments widen the search. Gravitational wave detectors like LIGO and Virgo listen for ripples in space-time itself. While most signals detected so far come from merging black holes and neutron stars, theorists wonder, could a faint background of gravitational waves exist? A hum from before the Big Bang. Such a signal would be revolutionary. Unlike light, which is absorbed and scattered, gravitational waves pass through everything. They could carry memory from epochs, invisible to photons, perhaps even from a pre-Big Bang cosmos. The relic older than the universe may not shine, but it may hum faintly. In space-time's fabric, the cold relics of neutrinos, another frontier lies with neutrinos, ghost-like particles that pass through matter almost unhindered. The Big Bang itself created a cosmic neutrino background, even older than the microwave background. Detecting it is one of the great goals of physics. But some scientists speculate, could relic neutrinos exist from before the Big Bang? If time is cyclic, or if transitions between universes preserve particles, then neutrinos could be messengers from epochs beyond creation. The accumulation of contradictions, investigation deepens the paradox. Stars pressing against the cosmic age, expansion rates that disagree, anomalies in the oldest light, theoretical particles and black holes that might predate time itself. Individually, each anomaly may be dismissed, a miscalculation here, a statistical quirk there. But together, they form a pattern, the possibility that the universe carries fossils from before its own birth. The whisper of prehistory grows louder by the early 21st century. The investigation had reached a strange place. Cosmologists continued to refine their models, confident in the Big Bang as the beginning. Yet the data refused to quiet down. The whispers of relics older than the universe grew louder, more insistent. It is here that the paradox begins to sharpen. If the Big Bang is not the beginning, then what is it? A transition, a bounce, a collision. The deeper the investigation went, the clearer the truth became. The relics, if real, point toward a universe not defined by a beginning, but by cycles, transitions, and histories we have yet to comprehend. The deeper the search went, the more the contradictions multiplied. What began as faint anomalies grew sharper, louder, impossible to ignore. The relics, whether stars, signals, or particles, refused to fit inside the neat framework of a universe that began 13.8 billion years ago. And with each discovery, the question sharpened: is physics incomplete, or did time itself not begin with the Big Bang? The Hubble tension widens. The Hubble tension, once a subtle discrepancy, grew into a wound at the center of cosmology. Measurements of the early universe, drawn from the Planck satellite's exquisite mapping of the cosmic microwave background, gave one expansion rate. Measurements of the nearby universe, Cepheid stars, type Ia supernova, and gravitational lensing, gave another dot. The gap grew with precision. No matter how carefully instruments were calibrated, no matter how models were refined, the two values refused to converge. If the early universe view is correct, the cosmos is older, perhaps easing the paradox of ancient stars. But if the local view is true, then the cosmos is younger, and objects like the Methuselah star truly predate it. This is no small error. It is a sign that something fundamental may be missing. New physics, unseen forces, or a cosmic prehistory pressing against our models. Structures that should not exist. Even more unsettling were the structures appearing far too early in cosmic history. Quasars, luminous beacons powered by supermassive black holes, have been observed less than 1 billion years after the Big Bang. Galaxies, rich in stars, massive in scale, emerged with astonishing speed. According to standard models, such structures should take far longer to form. Their presence so soon after creation suggests either that matter gathered in ways not yet understood, or that these objects carry a history older than the universe we measure, as though they were seeded by relics from a time before the Big Bang. The shadow in the sky, in the maps of the cosmic microwave background, lies one of the most persistent anomalies. The cold spot, a vast region of sky, hundreds of millions of light years across, slightly cooler than its surroundings. Some argue it is a statistical fluke, a chance cluster of fluctuations. Others propose it is the imprint of a supervoid, an enormous region of space with fewer galaxies. Yet others see in it a scar of something deeper, the possibility of a collision between our universe and another, before or during the Big Bang. If so, then the cold spot is more than a patch of sky. It is a fossil from a cosmos older than our own. Gravity's memory, gravity itself, may hold the key to these relics. Unlike light, which is scattered and absorbed, Gravity carries memory across ages. Gravitational waves ripple through space-time unimpeded, preserving signals from epochs unreachable to photons. Some theorists suggest that the fabric of space-time may contain imprints from before the Big Bang, subtle distortions frozen into the geometry of the universe. If detected, they would be relics not of our cosmos, but of the one that came before. This possibility redefines gravity not only as the force that binds, but as the archivist of reality, the custodian of memories too old for light to carry. Time. Without a beginning, the more evidence accumulated, the more cosmologists began to consider the unthinkable. That the Big Bang was not the beginning. Perhaps it was a bounce, the collapse of a previous universe reborn in fire. Perhaps it was a transition, a phase change in a cosmos that has no true start. Perhaps it was one bubble in an eternal foam, a local beginning inside an infinite multiverse. In each case, the relics are the fossils of what came before, a star whose age outpaces its host universe, a pattern in the microwave background hinting at collisions with other worlds, a particle that refuses to decay, surviving across cosmic epochs. If time stretches back beyond the Big Bang, then the relics are not paradoxes, they are evidence, proof that our cosmos carries memory older than itself, the weight of incompleteness for physics. This realization is both thrilling and terrifying. It means our most trusted frameworks, relativity, quantum mechanics, the Big Bang itself, may be chapters in a larger story, not the story entire. Relativity describes space-time. But what if space-time is not fundamental? Quantum mechanics explains particles. But what if particles are remnants of older fields? The Big Bang explains our universe. But what if our universe is only one cycle in an eternal chain? The relics whisper that the cosmos is incomplete, that the story is longer, deeper, stranger. That time may not have a beginning, only layers, one folded upon another. The escalation of mystery by the time the 21st century entered its third decade. The mystery was no longer avoidable. Observations had grown sharper, models more refined, instruments more precise. Yet the contradictions persisted. Stars pressing against the age of the universe. Expansion rates that refuse to agree. Galaxies and quasars appearing impossibly early. Anomalies in the oldest light. Individually, each might be explained away. Together, they form a chorus too loud to ignore. A chorus that sings of prehistory. The paradox had deepened. Either physics is missing something profound, or time itself did not begin with the Big Bang. And if time did not begin, then the relic older than the universe is no longer anomaly. It is truth. The paradox of relics older than the universe pressed science toward its most daring frontier. If the data could not be dismissed, if the anomalies were not illusions, then explanation required theories that reached beyond the known, and so physicists and cosmologists turned to speculation, not careless fancy, but reasoned imagination, tethered to equations, yet straining toward the unknown. Cycles of creation and destruction. One of the oldest ideas reborn in modern form is cyclic cosmology. In this vision, the universe is not a single creation but an eternal rhythm, expanding and contracting through endless ages. The Big Bang, then, was not the beginning, but the latest in a series of bounces. In such a model, relics may survive. Across cycles, black holes could persist, their information carried through transitions. Particles too stable to decay might endure the fire of collapse and expansion. Even patterns of structure could echo from one universe into the next. Subtle imprints surviving across eons. The relics that appear older than our cosmos would thus be fossils of previous cycles. Memories not erased but reborn. Penrose and the conformal cycles mathematician Roger Penrose proposed a variant of this idea, conformal cyclic cosmology. In his model, the end of one universe, stretched thin by expansion until matter decays and black holes evaporate, becomes mathematically indistinguishable from the hot, dense beginning of the next. Penrose even claimed to see evidence, circular, patterns in the cosmic microwave background, which he interpreted as the final whispers of black holes evaporating in a universe long gone. If true, the microwave background is not only a relic of the Big Bang, but a palimpsest, carrying the faint script of previous universes beneath our own. String theory and colliding Branislander speculations arise from string theory, where our universe may be a three-dimensional brain floating in higher dimensions. In some models, the Big Bang is explained as the collision of brains, a violent impact that ignites a universe. If brains collide repeatedly, universes may be born in succession, and if higher dimensions persist across these collisions, relics may drift between them, particles, gravitational waves, or other imprints carrying memory from one cosmic epoch into another. The false vacuum and bubble. Universe's quantum field theory raises yet another possibility. Our universe may be trapped in a false vacuum, a state not of ultimate stability but of temporary balance. In this scenario, the Big Bang may have been a bubble nucleation, a transition from one vacuum state to another, but bubbles do not form alone. In the wider multiverse, countless other bubbles may exist, each with its own laws of physics, each with its own timeline. If relics can cross the boundaries between bubbles, or if collisions between them leave scars, then the anomalies in our sky may be the fingerprints of other universes. The cold spot, the alignments, the unexplained signals, all could be evidence of bubble collisions, relics of realities older than our own. Eternal inflation and the multiverse from the theory of inflation. The exponential expansion of the universe in its first fractions of a second emerges one of the boldest ideas. Eternal inflation. In this view, inflation never ends everywhere at once. Instead, pockets of space stop inflating, forming universes, while the greater multiverse continues. Our universe is one such pocket. Others may be infinitely older, stretching back into an eternal froth of creation in this picture. Relics older than the universe are not paradoxes. They are inevitable. Every universe carries traces of others, either through collisions, quantum leakage, or shared ancestry in the infinite inflationary sea loop. Quantum cosmology and the bounce another approach comes from loop quantum gravity, which seeks to unite relativity with quantum mechanics. In this framework, space-time itself is quantized, made of discrete loops of geometry. When the density of the universe grows too high, these loops resist collapse, causing a bounce instead of a singularity. The Big Bang, then, was not the birth of time, but the rebound of a collapsing universe. Relics may have passed through the bounce, surviving from the prior epoch. If true, every ancient star, every unexplained signal may be a fossil of a universe before ours. Particles as fossils. Most tangible relics may be particles themselves. Primordial black holes, formed in the extreme densities of the early universe, or in a pre-Big Bang epoch, could still drift through space. Invisible yet massive. Ixions, stable and nearly undetectable. could form dark matter seas stretching across universes, sterile neutrinos, immune to ordinary forces, might carry memory from before the hot Big Bang. If any of these are detected, they would be direct evidence of relics older than our cosmos, matter untouched by the fire of creation, the multiverse and anthropic reasoning some scientists embrace. The multiverse not only as explanation, but as necessity. If countless universes exist, then most are inhospitable to life. Only a rare few, those with the right balance of forces, the right amount of dark energy, the right physics, can harbor observers. In this view, the relic older than the universe is not anomaly, but inevitability. We exist in a universe that allows for life, and relics are the fingerprints of a larger reality in which our cosmos is but one among countless others. The price of speculation, yet each of these theories comes with a price. Cyclic cosmologies require physics not yet proven. Penrose's patterns remain disputed. String theory's brains are elegant but untested. Eternal inflation raises questions of testability. Loop quantum cosmology is still in its infancy. Particle relics remain hypothetical. Speculation stretches science to its edge, where imagination must walk hand in hand with mathematics, and where certainty gives way to possibility. The expansion of mystery, but together. These theories share a haunting vision. The Big Bang was not the beginning. It was an event within a larger, older, deeper reality. The relics older than the universe are not mistakes, not illusions, but messages, fragments of truth that point beyond the boundary of time we thought absolute. And if even one of these theories is correct, then the relics are the keys to a greater cosmos, one where universes rise and fall, where time stretches without true beginning, where reality is a tapestry far larger than we ever dared to dream. Theories alone cannot solve the paradox. To know whether relics older than the universe truly exist, evidence must be sought in the sky, in the vacuum, in the hidden tremors of space-time itself. And so, humanity has built a constellation of instruments. Telescopes, satellites, detectors, each designed to test the limits of knowledge. In their silence and precision, they form the bridge between speculation and truth. Telescopes that see time, the Hubble Space Telescope, launched in 1990, became the first great sentinel of cosmic time. Suspended above Earth's atmosphere, its sharp eye revealed galaxies so distant their light had traveled billions of years. It showed a universe dynamic and restless, its galaxies colliding, merging, growing. Most of all, it measured type Ia, supernova, refining the cosmic expansion curve that first revealed acceleration. But Hubble was only the beginning. In 2021, the James Webb Space Telescope opened its golden mirror to the infrared sky. Unlike Hubble, Webb can see the faintest, reddest light photons stretched by billions of years of expansion. With this vision, it peers into the first galaxies, the first stars, and perhaps structures that seem too mature, too massive, too early. If Webb finds galaxies older than the universe should allow, it will sharpen the paradox of the relics. On Earth, the Vera C. Rubin Observatory prepares to survey the entire southern sky every few nights. Its legacy survey of space and time will record billions of galaxies, tracing how they cluster and how their light bends under gravity. If dark relics, primordial black holes, or hidden matter shape the cosmic web, Rubin's maps may reveal their fingerprints. And in orbit, the European Space Agency's Euclid telescope has begun its work, mapping the geometry of the universe, seeking the subtle distortions that reveal the tension between dark matter, dark energy, and perhaps something older than both, listening. To the oldest light, the most ancient messenger, is the cosmic microwave background, the afterglow of the Big Bang itself. Satellites like COBE, WMAP, and Planck have mapped its faint ripples with extraordinary precision, extracting the universe's age, composition, and geometry. Yet, within the smoothness of that glow lie anomalies, alignments, cold spots, unexpected symmetries. Future missions, even more sensitive than Planck, aim to test whether these features are statistical noise or the scars of a pre-Big Bang cosmos. If confirmed, they would be relics etched into light itself, older than the universe they illuminate. The search for relic waves light carries memory only from the time the universe became transparent, 380,000 years after the Big Bang. But gravitational waves, ripples in space-time, pass through everything unimpeded. They could carry messages from the first instance, or even from before. Since 2015, the LIGO and Virgo observatories have captured gravitational waves from colliding black holes and neutron stars. These are violent local events, but in the background, theorists predict a faint cosmic hum, relic waves from the earliest epochs. If detected, they would open a new window on time before time, a direct channel into PREHISTORY, the future space-based observatory LISA, planned for the 2030s, will be sensitive to slower waves, the whispers of supermassive black holes, perhaps even echoes from universes beyond. If the relic older than the universe sings, it may sing through these waves. The ghosts of neutrinos, another path lies in the ghostless particles of all neutrinos. The Big Bang left behind not only a background of photons, but also a background of neutrinos, a sea of particles that decoupled just seconds after creation. Detecting them would be like touching the universe's first heartbeat, but some speculate further. If time did not begin at the Big Bang, there may be neutrino relics, even older, carried across cycles or transitions. Underground detectors in mountains and ice are built to capture these elusive messengers, waiting for a rare interaction that might reveal the oldest relics of all. The language of particles in Geneva. The Large Hadron Collider smashes protons together at near-light speed, probing the vacuum itself. Its discovery of the Higgs boson was a triumph, confirming the mechanism that gives mass to matter. But physicists hope for more. Hints of axions, stellae neutrinos, or other exotic particles that may have drifted through cosmic history from before the Big Bang. Even null results carry weight. Each experiment narrows the possibilities, carving away what the relic cannot be, tightening the lens through which truth must pass. The patience of cosmology, these tools do not promise swift answers. They require decades of building, calibrating, observing, refining. Data arrive as whispers, requiring years of analysis to interpret. The relics older than the universe will not reveal themselves easily, for they are buried in the faintest signals, hidden beneath noise, scattered across the vastness of time. Yet this patience is not weakness. It mirrors the cosmos itself, which unfolds in billions of years. The search for relics is not a sprint, but a vigil, a long watch kept by humanity across the dark, listening for the faintest echoes of a deeper past. The edge of the possible, and here lies the greatest challenge: how to test what may be If the relics truly come from before time, can they ever be measured? If they are older than the universe, can they ever be proved? Science answers not with despair, but with ingenuity, by mapping galaxies, by listening to gravitational waves, by catching ghost particles, by smashing protons. It pushes the boundary of what is observable. Each experiment is a bet that reality leaves traces, that the universe cannot entirely hide its history, and so the search continues. Night after night, telescopes gather photons. Detectors wait in silence for ripples and ghosts. Colliders probe the vacuum. Scientists sift through noise for patterns that do not belong. If relics older than the universe exist, these are the instruments that will find them. And when they do, the foundations of cosmology will shift again, and the story of the universe will open onto something even older than itself. At the end of the investigation, after the telescopes and the equations, after the speculation and the searching, one question remains, not scientific, but existential. What does it mean to live in a universe where relics may be older than the universe itself? The fragility of beginnings for centuries. Humanity longed for certainty about origins. Myths told of gods who carved the world from chaos, of fires that lit the sky, of eternal cycles of death and rebirth. Science replaced myth with a new narrative. The Big Bang, the moment when time began, when energy condensed into matter, when all of creation was set into motion. The Big Bang was not only physics, it was philosophy. It gave the universe a beginning, and with it, the comfort of order, a book with a first page. But the relics whisper otherwise. A star whose light predates its cosmos. A pattern in the sky that seems older than creation. Particles that may drift across boundaries of universes. These hints suggest that beginnings are fragile things, perhaps illusions drawn by limited vision. If something can be older than the universe, then the universe itself is not the beginning. It is only a chapter in a longer story, one written on pages we cannot yet read. Time without origin, what is time if it has no true starting point? Perhaps it is a cycle, repeating endlessly. Perhaps it is infinite, stretching without beginning or end. Perhaps it is layered, each universe a page stacked upon another, the relics seeping between them like ink through paper. To live in such a cosmos is to live without the certainty of origin. There may never have been a first moment. There may never be a last. The relic older than the universe is not only anomaly, it is revelation, that time itself may be deeper than all beginnings. The humility of knowledge, this realization demands humility. Science, for all its triumphs, is provisional. The models that once seemed unshakable, Newton's gravity, Einstein's static cosmos, the certainty of a universe with a beginning, all yield to deeper truths. The relics remind us that even our greatest frameworks are incomplete shadows, cast against a reality stranger than imagination. If time did not begin, then the scope of reality dwarfs every human story. And yet, within that vastness, humanity has glimpsed the paradox, measured the anomalies, dared to ask questions that touch the edge of existence. The place of humanity in the infinite, in the immensity of such a cosmos. Humanity seems impossibly small, a brief spark of awareness on a pale world orbiting an ordinary star. And yet, that spark is enough to wonder, to measure, to recognize the paradox of relics older than the universe. This act of recognition is itself profound. It means the cosmos is not silent. It speaks through stars, through light, through particles, through patterns in the microwave background. And humanity, fragile though it is, can listen. In that listening lies meaning. To be a creature capable of asking about time before time, of imagining a history older than creation, this is too, be woven into the very mystery of existence. The echo of eternity of relics, older than the universe, are real. Then eternity itself echoes through them. Each is a fossil not of matter alone, but of history. A whisper from a cosmos beyond our own, carried across transitions, across fires. Across silence, the Methuselah star is not just ancient, it is a messenger. The cold spot is not just an anomaly, it is a scar. A particle drifting unseen may not just be exotic, it may be immortal. These relics remind us that the universe is not a closed book. It is an open library, shelves stretching beyond sight, volumes written in languages not yet learned. The final meditation, perhaps the ultimate lesson, is that beginnings and endings are illusions of perspective. To the cosmos, there may be no true origin, no final silence. There are only transformations, energy to matter, matter to light, light to darkness, darkness to creation again. The relic, older than the universe, is not contradiction. It is continuity. A sign that creation does not erase, but carries forward, that time does not start, but flows. That the cosmos is larger than the concepts humanity clings to. And in this realization lies both terror and beauty. Terror in the knowledge that human notions of permanence are fleeting against eternity. Beauty in the recognition that for a brief moment, in a small corner of an infinite story, the universe has given rise to beings who can see its mystery, and know they are part of it. So the relic stands silent and immovable, older than the universe, older than time as we know it, not merely a puzzle of physics, but a mirror held to existence itself.